Hello! Today I would like to make a short presentation of Covid-Vis, a dynamic platform related to the exchange of technical knowledge for the development of scientific software aimed at battling the COVID-19 pandemic. It is a known fact that the pandemic has had visible effects in the world in terms of society, economy, and other parts of daily life. Of course, multiple efforts from governments and organizations have taken place to offer technological solutions not only for tracking cases but also for vaccination programs and spreading awareness of the virus. Concurrently, we have noticed that the international programming community has turned its attention to COVID-19 and has offered its assistance by developing open source and individual solutions and software. This community, which contains experienced programmers, novice enthusiasts, and other types of users, used question and answer portals such as Stack Overflow to ask their questions regarding problems encountered during the development of specialized software, guidelines, or the opinions of other users on code snippets and other things. Thus, we have decided, in our latest research work, to gather questions from Stack Overflow related to the development of scientific software aimed at tackling COVID-19 and visualize the results in a collective platform that would present graphs and information on user engagement and utilize technologies. The platform was developed during and after the pandemic and is constantly updated with new data every week. In this video, I will present the platform architecture, discuss its main components, and run a short demo to illustrate its usage. The results of this platform are highly useful in many target groups, such as researchers who want to gain insights on technological development during and for the pandemic, open science supporters who can catch a glimpse of voluntary efforts in software development, as well as simple users that want to inform themselves on the subject of scientific software development. More use cases are described in our research paper. To begin, I would like to present an example of our main source of data, which are questions in Stack Overflow related to software development for COVID-19. In my screen, which should be okay, in my screen I have an indicatory question where we see some really interesting features such as the title, the body of the question, several metadata such as the views, the votes, the timestamp, and some code snippets. In addition, we can see the tags which express the technological objectives of the question. Here this question has only one tag, R, and the user that asked it. The user asks as the owner of the question and carries his or her own features such as geographical location, description of his profile, and other things. We are currently only interested in the geographical location of the user. So we have collected for each question all these features and we pass it directly to our preprocessor component. Let's move on and say a few words for the platform architecture. A detailed description of the architecture can be found on our research paper. The data collector is responsible for collecting questions and extracting features. As we can see, we have applied a search string and taken question entries. Then we extract some features such as the title, the body, the user, location, metadata, which are answers, comments, views, and votes, timestamp of the question, the tags, the user and question IDs. The question tags are categorized in technological domains that capture broader technological scopes. The domains can be seen here, and each one contains various related tags or technologies. We can see, for example, that the technological domain of languages contains tags that are directly relevant to programming languages used for data analysis, data manipulation, software development, and other fields such as Python, Java, R, JavaScript, C++, and other technologies. The web frameworks are different from languages, and they contain specialized software used for creating platforms and software such as Angular, Vue.js, React, Flask, and other frameworks. The other domains express other technological scopes such as technologies for big data, developer tools, which are integrated programming environments, collaboration tools such as GitHub, GitLab, Mercurial, and other tools, platforms for deployment, Linux, Docker, Kubernetes, and other platforms, and databases such as MySQL, Redis, MongoDB, and other databases. Apart from that, let's go back to the architecture of the platform. Apart from that, the preprocessor is responsible for transforming the unstructured data in useful information before storing them to our backend service. Let me show you our backend service, which consists of a MongoDB database. As we can see here, the questions are stored here, with each question carrying fields which are features. For example, this question here, our first question, carries a timestamp, an owner ID, votes, views, the question ID, body, and title. Currently, the user of the question has no location, the tags, whether the question has a code snippet, comments, answers, if it's closed, and the first answer, though this is still not integrated in the platform. The communication between the backend and frontend elements, along with the backend and the rest of the components, is done via the Flask framework, a well-known development framework in Python. So, it is time for a short demo to present the platform and its functionalities. So, I will open the localhost here and run the frontend service. The platform runs locally for now, but we plan to deploy it online soon, with additional operations added such as more communities, extra features, and more methodologies. So let's press here. This is the main environment. We can see that at the top we have the platform state cards, which load some basic information and metadata. On the first execution of the platform, this displayed information covers a period from January 1st, 2020 to September 19, 2022. It covers the whole period of data collection. We can change the dates from here and view the data in different time periods, which I will show later. The platform is fully responsive in all devices, as we can see adjusting the screen size. Let me just show you this. So if we go here, we can see that the platform is fully adjustable to a mobile phone, and as we grow on a tablet, and other screen sizes. So let me close this for now. Scrolling down from here, we can see a line chart depicting the posted questions for each week, which allows to portray user interest in pandemic-related software. The chart supports a cumulative function for a more collective view. Next, we have the profiling of tags, with a word cloud containing the most used tags and questions, and a more contained bar chart with only the top 10 technologies. As we can see, the tags refer not only to programming languages and frameworks, but also to procedures of data analysis, such as data visualization and deep learning. We also have an interactive map that shows countries of the users that posted questions. By hovering, we can see that each country corresponds to a dot, along with the number of questions associated with it. For example, New Jersey has 2 questions, Philadelphia has 11 questions, and so on. For a more comprehensive view, we also provide a heat map that shows areas with more questions like Europe, United States, India, and more. Further down, we have a radar chart that visualizes the distribution of tags among the technological domains, with languages being the most prominent. Next to that, we provide the percentage of questions with code snippets, which most of them have, actually almost 90%. This is expected as most users want to provide the code that they want help with. The platform also supports a function for sorting questions based on their votes, answer, or comments, with more features like views and bounties to be added in the future. We can see that if I change the sorting criterion, for example, let's say from votes to answers, the top question changes, while we also provide the links to each question from here. We can also change the types of questions we want to sort by choosing questions that have tags belonging to a certain technological domain. For example, I am now sorting the web frameworks focused questions according to their votes. Next to that, so we can see that we have links to the top questions as well. Next to that, we have a table of the top users based on the number of posted questions with a link to the user profile here. Finally, the last current element of the platform is a visualization of the Lda algorithm that extracts topics from the question titles, which helps us understand the thematic circles from the linguistic parts of the questions. Each circle is a topic, and the larger the circle, the most important a topic is. We can see that neither topic is too similar with one another as they do not overlap. If I hover on a topic, we can see the words that characterize it, which allow us to understand its concept and give it a short title. For example, topic 1 can be related to data analysis and manipulation with words such as data, Python, plot, R, and map. Topic 3 could be interpreted as web scraping and mining with words such as API, React, JSON, HTML, and table. For example, topic 8 can refer to platform deployment or machine learning model deployment with words such as project, model, deploy, Heroku, and classification. Let me now show you how we can view the same graphs from a different time frame. If I modify the dates from this window here, let's say I put the April of 2021 here and March of 2022. So here, if I search, if I modify the dates, we can see first of all that the metadata change according to the posted questions of this period. For example, we can see that the average number of comments, the number of answers, and the average number of votes have changed. Moreover, all the elements of the platform change accordingly, allowing the user to view different time frames and compare the findings and find trends. For example, here we can see that the line chart has changed, supporting only the time period that we have chosen, and the tags have also changed. While Python retains the advantage, here we have new tags such as SQL, data frame, web scraping, and the map is visibly less populated. So this is all for today. I hope that this was an interesting showcase of our platform, Covid-Vis. We plan to expand the platform with additional features and deploy it publicly. In the description below, I will have a link to our GitHub repository where the platform code can be found, and I will include the platform URL once it is deployed officially. Thank you very much for watching.